Let's take a look at questions where we're asked to consider flipping a fair coin. I have two coins here, but we'll just consider flipping a fair coin a certain number of times. So one side of the coin has Abraham Lincoln's head on it, so we would consider that heads toss if it lands that way. That's a little hard to see with the glare. And then the other side, the one without the head on it, is called the tail. So if we take one coin and we flip it, and if it's a fair coin, then we have a 50% chance of the coin landing with heads up and a 50% chance of the coin landing tails up. And that's assuming that we do have a fair coin. So when we flip a fair coin and record what happens, if we only flip the coin one time, it's not terribly interesting. What we will try to do is flip a fair coin multiple times and think about what could happen to us. So in our situation, let's flip a fair coin 4 times, and let's think about all of the possible outcomes that could happen. And when we make a list of all of the possible outcomes, that's called the sample space. Before I make this list, I would like to know how many things should be in my list, how many outcomes. So if we toss a coin 4 times, I can draw slots for the 4 tosses. The first toss could either be heads or tails, so there are 2 options for that toss. Same thing for the second toss, 2 options there, 2 possibilities for the third toss, and 2 possibilities for the fourth toss. The multiplication principle of counting says we would multiply all of these together to get 16 possible outcomes in this situation. So when we list the sample space, there should be 16 items in it. You can see if we had 5 tosses or 5 flips for the coin, we would have 5 slots, and then we would have 32 possible outcomes, and that's a lot to list. So probably in Math 115, we're only going to be talking up to maybe 4 tosses if we have to make the full list. All right, let's start making our list. If we had to list everything that could happen to us, it could be the case that 4 heads are flipped. So I'll just list that as 4 H's for 4 heads. We could have 4 tails being tossed. So I'll use T's for those, 4 T's. That would be 2 of our outcomes. And then we have the situation where we could have tossed 1 tail and 3 heads. And that tail could either be in the first spot or the second or the third or the fourth spot. So we have to list all of those. Oh, darn. I listed that sooner than I wanted to. There we go. So the tail could be in the first spot, the second spot, the third spot, or the fourth spot, and all the rest would be heads. We can do a similar thing with 1 head and 3 tails. And when we do that, here again, the head could either be in the first spot, or the second spot, or the third spot, or the fourth spot. So we need to list all of those. All right, so far we have 4, 8, 9, 10 of our 16 possible outcomes. There are 6 more to go. We've done the situations where we get all heads, all tails, 1 tail and 3 heads, 1 head and 3 tails, and so the remaining 6 are the situations where we get 2 heads and 2 tails. So 2 heads and 2 tails. They could be arranged in any order. So we need to get all of the orderings for that scenario. Right now I have the 2 heads first and the 2 tails last. I could reverse that. 2 tails first, 2 heads last. We could have heads first and last with the tails coming in the middle, and then we could reverse that with the tails first and last and the heads coming in the middle. And then we could have the situation where things alternate. Heads, tails, and we could reverse it, tails, heads, tails, heads. And now I think we have all of them. We have all 16 possible outcomes. So if you are asked for what are all the possible outcomes, we would need to have a list. If we're asked how many possible outcomes there are, we can figure it out with the multiplication principle of counting. There are 16 in this case. Once we have this list, we can start to answer some questions. So keep that list handy, and here are some questions for us. If a fair coin is flipped 4 times, what is the probability that... First question is, well, what about 4 heads being flipped? That would be this scenario, 4 heads. And if you look back at the sample space, that only occurs 1 time out of 16 occurrences or 16 items in the sample space altogether. If we take this quantity and convert it to a decimal, we'll get 0.0625. And if we convert that to a percentage, either by multiplying by 100 or moving the decimal point right 2 places, we'll get 6.25%. If we flip a fair coin 4 times, 6.25% of the time we would expect that we would have 4 heads occurring. In letter B, I have 1 tail being flipped. We're looking for a probability of that. I'm going to add an extra word in here. Let's make sure it's exactly 1 tail being flipped. Let's think about all the ways that could happen. For 1 tail being flipped from our sample space, the tail could have come first, followed by heads, or the tail could have come second, or the tail could have come third, or the tail could have come fourth. Those are all of the cases where exactly 1 tail is flipped. So there are 1, 2, 3, 4 situations where that happens out of 16 possible items in the sample space. Let's reduce this to lowest terms. If you divide both the numerator and the denominator by 4, this will reduce to 1/4. If we convert that to a decimal, we will get 0.25, and as a percentage, this would be 25%. All of these are equivalent values. How you phrase your answer depends on the instructions, and it depends on the scenario. It might be the case where 1/4 is a really powerful, good answer to a question, and it might be the case where 25% makes better sense. Kind of depends. Last one, letter C, we would like at least 2 tails being flipped, at least. And that means that we could have 2 tails, or 3 tails, or 4 tails. At least 2. For this one, this is a lot of things to consider, and you might notice 2 tails or 3 tails or 4 tails, it's a lot of items in our list. I'm going to put the sample space that we wrote out, I'm going to put it back up here and use it. So in here, at least 2 tails would be all of these and all of these and this one. So let's count those up. There are 6 here, 4 more here, 2, 3, 4, 5, 6. Yep, 4 more here. And then 1 more for this last set that is all tails. So 6, 7, 8, 9, 10, 11. 11 out of 16. So the probability here would be 11 out of 16. That does not reduce any further. It is all the way reduced. If we ask for a little calculator help for 11/16, the decimal version is 0.6875. And if we convert this to a percentage, this will be 68.75%. So if we flip a fair coin 4 times, and we would like to get 2 tails, at least 2 tails, we will be looking at 68.75% chance of that happening.